Now we have a couple of other summation formulas that are going to be important for you to recognize and also memorize. So here we have the sum as I goes from 1 to n of a constant. So what's going to happen with this is that constant is going to get repeated and added together a total of n times. And so this is really going to be c times n. No need to write it all out because it's going to always be c times n. Now in number 2, here we have the summation of just a single variable I. And the way this one is going to always work out, it's going to look like this. N times n plus 1 divided by 2. And you might also see this as n squared plus n over 2 if it's just multiplied out. So what these really are, they're shortcuts for finding these summations, okay, without actually having to expand the whole thing out. So here, if we have I squared, we get n times n plus 1 times 2n plus 1 all over 6. And another way you might see this, if we distributed all this out, we would get 2n cubed plus 3n squared plus n over 6. And the last one, if we have an I cubed, we get n squared times n plus 1 squared over 4. And again, if we multiplied all that out, we would get n to the 4th plus 2n cubed plus n squared over 4. Okay, so using these formulas can become necessary if we have an example like number 4. It says use properties of summation and summation formulas to evaluate the sums. And so we're looking for S of n, so the sum at n, and we have I going from 1 up to n. So notice, because we don't have an end point, how are we supposed to evaluate this sum, because it would never end? Yes, we could write it in expanded form, but we're actually trying to evaluate it. So what we're going to do is try to use our properties and the formulas to get an answer here. So the first thing I want to do is go ahead and factor out my constant. And my constant in this case is going to be my n squared. So I'm going to take out a 1 over n squared here, and then I'm still going to have my sum of I going from 1 to n, and now all I'm left with is I plus 1. Okay, and now we can break up this sum. So we still have our constant out in front, but we're going to break this into two sums now. 1 for I equals 1 to n of I, and then 1 for I equals 1 to n of 1. Okay, so if we just continue with this a little further, we still have our constant on the outside. And here's where we can use our properties. So I equals 1 to n of I. Well, that is this one right here exactly. So we can just rewrite this as n times n plus 1 over 2. Okay, and then here I equals 1 to n of 1. Okay, 1 is just a constant. So now we're looking at our first formula right here. So it's going to be c times n, or the constant times n. So in this case, it's just going to be 1 times n. Okay, so now what we've done is we've replaced all of our sums, and now all we have is n's. And so let's go ahead and clean this up a little bit to find what s of n equals. Okay, well, looks like I can factor out one of these n's here. Okay, so that n and this n, we're going to factor out greatest common factor. And then we're still going to have inside, let's see, this is n plus 1 over 2. And then if I factored an n out of here, I still have a plus 1. Okay, so n over n squared is just 1 over n. And if I wanted to combine these with a common denominator, I would change my 1 into 2 over 2. And so I have n plus 1 plus 2, which is n plus 3. And now it would be over the common denominator of 2. And then I would simply just multiply across. So 1 times n plus 3 is n plus 3. And then n times 2 is 2n. So right here, this is your s of n. Alright, so even though we didn't know what n was, we could still evaluate our sum. Now moving on, letter B says evaluate the sum s of n when n equals 10, 100, 1,000, and 10,000. Okay, so let's go ahead and find s of 10. All we'd have to do is plug in 10 for n, so 10 plus 3 over 2 times 10. And that gives me 13 over 20, which is 0.65. If we wanted to evaluate s of 100, we would plug 100 in here. So we'd get 103 over 200, and that is 0.515. Let's see, s of 1,000. That would be 1,003 over 2,000, which is 0.5015. And then s of 10,000. Okay, so we'll just do that up here. That would be 10,003 over 20,000. And this is 0.50015. Now what we're doing here is not just plugging in some random numbers for n. What we're doing is we're increasing n, and you can kind of see a pattern of what's happening to our values here. And you can see it very clearly also right here. So here, 13 over 20, 103 over 200, 1,003 over 2,000, 10,003 over 20,000. What we're getting closer to is as we increase n to infinity, this value is going up to 1/2. So a very important thing that we're trying to get to here is the limit as n goes to infinity of our original sum problem. So I equals 1 to n of I plus 1 over n squared equals 1/2. Okay, so that idea of a limit is going to come back in this chapter, and we're going to put these pieces together a little bit more later. For right now, just focus on being able to apply these formulas. All right, next I want to give you a chance to do some practice here, using the properties and the formulas to evaluate these sums, and then also to write the following sums in sigma notation. So go ahead and do these problems and bring them to class with you.